Hi, this is Dr. Pat. We are doing system of equations. Going to just do a nice little example, just kind of start this all off. Show you the graphical approach, the approach for substitution, and then the approach for elimination. So, three different ways of getting the answer. All right, so we've got a system of equations. We're just playing with two equations in this case. We have two unknowns. Those are the variables that we have. So, we have an x and a y and two equations. So if this all works out, if they're parallel lines, we have no hope of getting a solution, but if they're not, then we'll have where they cross. Okay, so what I do is basically I take my equations and I solve them for y equals, tap them into my calculator, get a nice little graph. So the graph that you see here is this nice standard screen of negative 10 to 10 and negative 10 to 10 here for, in the x direction, negative 10 all the way to 10, and from the y direction, negative 10 to 10. So nice standard screen. And basically, we are looking for where they intersect, where they cross. They happen to cross right here. And to find that point, I basically just kind of do see where the x value is, how far to the right, and then how far down, and I get an x value of 5 and a y value of negative 6. So there's our solution. Nice, straightforward for when you've got the graphs. Now, let's take a look at an algebraic approach. We'll do the substitution method first. In the substitution method, you basically take one of your equations. It does not matter which one you pick. Just pick one of them and pick the easiest one. So I just decided to pick that first equation. I brought the 2x over to the other side by subtracting. That's why you see a minus 2x there. I solved for y, so that's what I'm doing. I'm taking one of the equations, I'm picking one of the variables in that equation, and I solve for it. Then the next thing we do is we take that result. See, we have a statement, y is equal to 4 minus 2x. That means in the other equation, wherever we see a y, we can put in what we solved. We see a 4 minus 2x for the y. It's a substitution. That's why they call it the substitution method. Ooh, how original. And then basically we take that. Now we start working this single equation that we have because it only has x's. It doesn't have any y's anymore. We can take that and solve for it. Let's see. I put the two x's together. Then we bring the 4 over to the other side by subtracting 4 from both sides. Then we'll divide both sides by negative 4. And we get an answer of x equals 5. Now I do have to warn you for a second. It seems like, hey dude, we're all done. I got my values. But we're not done because with the system of equations, we're looking for the x and the y value, the point, and the point has an xy value. So that's what we've got to do so we don't just stop here. Remember, take that 5, go back to that equation and plug in for the x. And by doing that, we solve that, we get negative 6. So our data point that we get from this algebraic approach using the substitution method is 5, negative 6, which is exactly what we got from the graph. So it's working out good. A second approach that we have algebraically wise is elimination method. Okay, now this is a little bit different. What we're going to do is we're going to combine the two equations together to eliminate one of the variables. So we're going to work vertically here. I'm going to add these two equations together. I'm going to add the x's together, combine them. Going to combine the y's together and combine the numbers together. So basically when we do that, when we combine the x's, because one is positive 2x, the other one's negative 2x. When you get that, you get a 0x. Getting the y's together, we got 2y. Combining the numbers together, you get negative 12. So the elimination method is to combine the two equations in such a way as that you create a 0x or a 0y. And so that's what we got here. Our next step, because this 0x is basically nothing for us, is to solve for y by dividing both sides by 2. And we get y equals negative 6. But once again, we're not done there yet. Don't stop. We've only got the y value. You got to get the x value. So what you do is you pick one of your equations. Again, doesn't matter which one you pick. Pick one of the equations and plug the negative 6 in for. I thought I'd pick the first one because it looked easier to work with. I don't know why. I just decided. And so then I plug in the negative 6 for that y value. And next step, is we got this equation. It only has x in it now. Let's solve for x by adding both sides of 6. Then let's get rid of that 2 to get x by itself. We'll divide both sides by 2 and we get x equals 5. And our solution once again is a 5 comma negative 6. So 3 different ways that we did it. We did a graphical, got 5 comma negative 6. We did algebraically with the substitution method, got the same data point. Now we just did the elimination method, got the same point. The key thing in the elimination method is we're combining the two equations and in such a way that we eliminate one of the variables. I hope this helped. Thanks. Have a good time.